They seem to be talking to that, it's not hard.
Yeah, I know. They just like to throw things on the show.
Oh, yeah. Okay, so yesterday, we're getting ready for a test. Yesterday, we began reviewing, we were on the sheet called Review 2628 Study Session, and we're ready for problem number 6. Okay?
That's about right.
So here we go. I'm mixing some stuff together. What is my formula for that? Who remember? Formula might be the wrong word. What is the setup for that kind of problem? Amount times percent. It's multiply. Amount times percent plus amount times percent equals amount times percent of the total. That's the total over there. So my percentages are known. I have some 12% that I'm mixing with some 18% to end up with some 14%. Does that make sense to everyone? Where's Ronan? I saw him earlier today.
I saw him earlier today too, I don't know.
And London. Okay, that's all right. Here we go. Some 12% and some 18% are mixed to get 50 gallons of 14%. Now, you guys listen, because this is what sometimes we do, and it's wrong. Some X mixed with some X. No, because if you call them both X, then they have to be the same amount. And do I know that they're the same amount? I have no idea. So I can call one of them X. Now I can call that Y, but I can't solve it with Y.
50 minus 8.
But if I call it Y for a minute, would you agree that X plus Y has to add up to 50? So Y is 50 minus X. So I'm going to put 50 minus X in there. Now my equation is solvable, because it's all X's. Everybody okay with that? Whatever you do, don't call them both X. They cannot both be X. All right, so 0.12X plus 9 minus 0.18X. I'm going to check that, trust myself. 0.18 times 50, that's a distribute I'm doing here. Equals 7. Now we need to add these together. Be careful. Again, this sounds so silly, but I know 18 minus 12 is 6, but it's not going to be 6. It's not going to be 0.6. It's going to be 0.06. Equals -2 if I move the 9 to the other side. So I got 2 divided by 0.06 here, 2 divided by 0.06. I got 33 1/3 gallons of 12%. So then how much 18% am I gonna have?
16 2/3.
50 minus that, so 18% is, what'd you say that is?
16 2/3.
16 2/3 gallons. So that would be the answer to the question. Everybody catch all that messing around we were doing in there to come up with the actual answer to the question? Rachel takes 3 hours to do a job. If Emma helps her, it takes 1 hour. How long for Emma alone? 1 over alone plus 1 over alone equals 1 over together. You don't need to write that down, but that's how I'm going to build my equation. So Rachel takes 3 hours. Emma helps, it takes 1 hour, so together is 1 hour. And I wanna know what Emma alone is. Does that make sense? Okay, so let's get a common denominator, 3x, that sounds good. So x plus 3 equals 3x. I got 1.5 hours, but I'm gonna let you check that for me.
It's good.
Looks good. Make sure you put a label on there. If it's a word problem, it needs a label. We good with that? Alright. What in the world? Number 8. Minimize the paper to accommodate 120 square inches of print with the indicated margins. Okay, so I have a piece of paper, and I am going to have some words in here. This is where my typing is, my story, or whatever is in there. But because of some reason, I need margins this big. So I'm putting together some kind of book or something, and this is how it has to look. And I need to minimize the paper if I have to have 120 square inches of print. Okay, does everybody understand what's happening? Okay, let's look at this little rectangle. I don't know what either of these dimensions are. Would you agree, these red dimensions? I do not know what either one of them are. But I know that if I times them together, I get 120. So if this one, if I call this one X, then you can temporarily call that one Y if you want. So X times Y is 120. But what does that make my Y then? Because I really don't want to use Y. So that one would be 120 over X. Does that make sense to you? We don't want two variables. Because if you have two variables, you gotta have two equations. And then you have to substitute, eliminate, and all that stuff. I don't want to do all that. So I want one variable. So are you with me that those are the dimensions of the red? Alright, this whole thing is the paper. So tell me about this dimension. All the way across, the purple. How big is that? What would that equal? 120 over X plus 4.5. Guys, look, isn't that 3? And then my 120 over X, and then my 1.5? So the whole purple across the top is that red plus these two. Now, what about the whole purple here?
X plus
X
3.2.
plus 3.2 times each other would give me my area. Minima, or that would be the size of the paper, that would be the area. So the area is 120 over X plus 4.5 times X plus 3.2. Is that good? Now, certainly that's a foilable thing, and you could foil it, but there's really no need to, because we're gonna go to our calculator, we're gonna graph it, and we're gonna look for the minimum.
Wait, what?
read the question.
Probably.
Here we go. Okay, so let's go ahead. If you wanna go, if you feel better filling that out, you can. But you don't need to. You need to use parentheses though if you don't foil.
People like that later.
And I am just playing with my window until I get something that shows me a minimum. Here is what I finally settled on. Again, there's lots of options. My X's were 0 to 80, and my Y's were 0 to 1,000. And when I graphed that, I got my handy dandy little Nike swoosh, so I could very clearly see my minimum. So minimum. So again, I just played around with it. Nobody's gonna be giving me that information on test day. You're gonna have to be patient, play around with it. Did you get 9.238, comma 217.538? Dana? Is that what you got?
Yeah. Is there a water fountain?
So we need to minimize the size of the paper. So that means we want the dimensions to be the smallest they can be, right? So X is 9.238. So remember, your dimensions were these things, right? So one dimension will be 9.238 plus 3.2, so 12.438. And then the other one will be 120 divided by 9.238 plus 4.5. So that one is 17.490. So the dimensions of the paper would be 12.438 by 17.490.
Do you multiply that out or is it size?
No, that's it. Those are the dimensions of the paper. Dana, if you multiplied it out, you better get this number right here,
Oh.
right? Because that's the area.
It doesn't matter.
Do we have to put like
Inches,
inches, like
yep. Thank you. Yep.
and we put it on the
Yep. have any question about that? Because I'm gonna have to erase it. Because it took so much space. Okay?
Yep.
All right. What are the excluded values? I don't even remember if I used that vocabulary with you or not. Anybody have an idea what I'm talking
Extraneous?
about?
Extraneous?
What would be the extraneous root? Yep, that's
X.
exactly right.
X plus 3, X minus
So, x plus 3, x minus 3,
3. And 0.
and 0. So x equals, x can't equal
Negative 3.
negative 3, 3, or 0. Now, I know what some of you are thinking. You're thinking, but wait, I can cancel that out. You can, but remember, what would that do graphically? Wouldn't that put an open dot? So even though you can cancel it out, you still can't be it. That still can't be included.
Still on the top right.
So negative 3, 3, and 0 would be the excluded values. The question is not asking you to solve. It's just saying what can x not be. Good on that, guys? Okay?
Yeah.
Sketch, label everything. All right, this is huge. All right, here we go. How are we gonna start?
You can factor.
Factor everything, so the top factor
X
is
minus 4.
minus 4 plus 3.
Yep. And then you can take a 2 at the bottom.
If I pull a 2 out of the bottom,
You could already said you're at horizontal.
then it factors as
X
plus 3 minus 1. And we can cancel. So we are going to graph that. Now Elijah said, I think it was him, said that even before doing all this stuff, I know my horizontal asymptote is going to be 1/2. And that's perfectly okay. You're absolutely right. You can tell that right from the beginning. So your horizontal asymptote is y equals 1/2 from either boxing in these or boxing in these. It doesn't matter. Y equals 1/2.
The vertical is positive.
Vertical is where x equals 1. Now, if you tried to do the vertical from back here at the beginning, you'd be in trouble, because that is not gonna be a vertical asymptote, even though it's in the denominator. It's going to be a hole. So we're gonna have a hole where x is negative 3. Right?
Yep.
And then we'll plug it in right here. So negative 3 minus 4. 2 times negative 3 minus 1.
So 7/8.
7/8. So negative 3, 7/8. What does that tell me, my numerator?
Yeah. So 0 at 4.
0, and so at 4, the value of the function is 0. How do I find my y-intercept?
Plug in zeros for the y.
Plug in zeros for x.
I mean x on it, yeah, that's right.
So that would be
Obviously.
negative 4 over negative 2. Right?
Mm-hmm.
And then, draw a picture. All right, are we okay with that. Because now we're going to use limits to describe all the asymptotic behavior. So I have one asymptote at 1, x equals 1. So what is the limit as x approaches 1 from the right? Now on test day, I'll have this written out for you, okay? You won't have to write this out. I was just lazy and running out of
Negative
It's
2.
going down.
Negative
And then, well, wait a minute.
Oh.
And then x approaches 1 from the other side. And then x approaches infinity. And x approaches negative infinity. So these limits describe what's happening with the asymptotes. Okay, but that'll all be written for you, but you will have to answer these questions. So, as we approach 1 from the right, we're going down. As we approach 1 from the left, we're going up. As we approach infinity, remember, x approaches, this is x. X goes to infinity, that's this way. What's happening? I'm getting closer to the left from the bottom. And as I go to negative infinity, I'm getting closer to a half from the top.
Oh. So we have to put a
That's a good description right there of what's happening at the asymptote.
So we have to put a positive and negative. What are you doing? Oh.
Alright? You good? 11 is a calculator problem. All this, by the way, was no calculator.
Yeah.
This will be on the white part of the paper. 11 will be on the
Green part.
green part. Alright, so you got a calculator. Full use of your calculator. You can do whatever you want to do. Who's got an idea?
Is it gonna be just
Move the 4 over and plug in the 4 over.
on the test? Is it gonna be like last time with
Some,
calculator?
yeah. Alright, so, one option is to move the 4 over. Now, did you hear me say one option? Remember, you're gonna do whatever you do. Alright, what do if I decide to move the 4 over, then what?
Plug into y.
Put it into y equals, and I'll be looking for what?
Intercept.
If I put in this, I'm looking for where it crosses the x-axis,
Yes.
right? These will be the zeros now. So if you choose to do this, you are looking for where it crosses
The X.
the x-axis. I only saw one place.
Yep. Negative 1.3.
Thank you, I haven't found that yet, but thank
So you
you.
get that. Negative 2.3?
I did not.
Well, what'd you get?
Negative
Oh,
0.6.
Yes.
I think Garden's the wrong one. It's negative 2.3.
I got negative 1.8.
0.67. There's 2.
There we go.
I got
What?
negative .674.
No.
Now, let me check my equation and make sure I put it in.
Oh, I forgot to put a plus sign.
Yeah, 1.3 as well.
Oh, come on, plus sign. Plus 4. Plus 4.
Alright, so if you choose to move the 4 over get something that looks like this, okay? And that would be the point that you are looking for. Now, this will work every time, it's fine, wonderful. Did anybody have a different thought when you looked at this problem?
Denominator gotta give not.
Could you have graphed this as one equation, this as another equation, and then figured out where they cross each other,
Yes.
right?
What was easier? Probably the first.
It's up to you. They're both about the same amount of work. This was absolutely fine. However you do the problem though, you gotta get this answer. So if you're not getting that, you're wrong. Jack? Stop. Okay, so that was one review. Now, turn to page 5. And page 5 says review, and then it's got a whole bunch, 2.6, 2.8.
What?
The first problem says what is the domain? Everybody on the right page?
Five is soccer.
It has 5 on it, of course. It's got a 5 here and a 5 here. So, where's Precal A, review 2.6 to 2.8, got it?
Yeah.
All right. Right now, Joe had a good idea. Right now, we're gonna, in our little group, with our partner or partners, we're gonna do problems 3, A, B, and C. All right, you're gonna do 3, A, B, and C. After you have finished, you're gonna come up and put one of them on the board, okay?
This is all Joe?
No, this is Joe's idea.
Oh.
But Joe's not doing it unless he wants to. I mean, everybody has the
Are
opportunity.
you kidding me, Joe?
So we're all doing number 3, A, B, and C. And then instead of me blabbing, you're gonna come up and show what you did. Anybody who isn't doing it is gonna start losing test points, okay? This review is for you, all of you.
Number 3, ABC.
Number 3, A, B, and C, the inequality.
Alright, so you minus 2, get it.
Do you lose the denominator?
You can use your notes if you wish.
Owen, are you doing A?
Oh, no.
Did you lose the denominator? Did you keep it? For after you do that?
No, all the way on.
I mean, you don't get it to it.
Okay, thanks. Why matter?
You guys get negative X.
These are no calculator problems, so we should not be using
Negative X
calculators.
was fine. Yeah, I got it. But you gotta do it equal to 0. You can't. It's gotta be bigger than 0. Wait, how do you plug one of these?
1, 8.
I was plugging some negative, divided by 1, so.
1, sorry, 8, -1. Which is not.
Once you, if you lose it,
Yeah, once you.
it's not great, 0, so it must be just.
Now,
Yeah. Every other, so if it's not this one, it has to be.
Yeah.
We can group B, we can group B.
I got negative X plus
X plus 3.
I'm back right. Take a negative out.
But I got, I think you keep it, and then you yeah.
It'd be X equals 2 would be 1.
X minus 1 X plus 1 equals 2.
Because she always says.
We don't gotta move on to this one.
No, we're not supposed to do that. I'm wrong.
Open. One and 0. Scored always 0.
Zero, then it would be.
It's 4. Is this right?
Negative, positive, negative. No, negative, positive, negative, that is. Wait, it's not bigger than 0. It's not bigger than 0.
So which one are we numbers? Or less than 0?
Oh, 0 would work. Wait, 0 works.
You shade it, you don't shade it. Shade it, don't shade it, shade it.
Wait.
Oh my
Y'all have courage, go up there and put it on the board.
Oh my goodness, Smith.
Oh, come on.
Wait, no, that makes sense. Because, oh, 0 doesn't.
What? Is this what you got?
Negative 1 times positive 1.
Even for you.
Negative 1.
Jake, we didn't finish
Times
that.
negative 3. I don't know if it's 0. I just think 0. You're negative 4.
Oh, no.
3 to 5.
Yeah, I just
Negative 3. Positive 15.
So you get the 9 from negative
Negative 1.
Yeah, I know. That'd be negative 4. Joe, go put it here.
Do none of them work?
Yes.
Anna, what did you do?
This floor, what'd you get for Ed? 2, come on, 9.
I'm gonna send you
2, no fun this floor, no fun this
And then you plug 4 in, and
floor.
positive.
You know you're not even gonna win.
I see. I don't get in.
Let's see what you have it open.
That's what, because the plus is bigger than the
You win.
You actually think you're because you shaved his head. It's so sad. We all over the they're just like
That's so
they're really and annoying you.
You suck.
Wait.
Actually, in my house, first time she ever came to my house, she like choked me. And I was like, get out of my house.
Yeah, first, yeah, negative, negative, positive.
Joe, you know you need a thousand before not getting the
She's built like this. Marshall Bridge. Break train.
I don't think we did.
Alright, guys.
I told you that because
Did problem A.
we did. And it was Joe Garvey, all Joe Garvey.
Oh, yeah, it was definitely all me. Is that right?
Oh, come on.
Yeah.
No, it was me. It was me.
Joe Garvey is right.
Yes, she has.
This is what you got, let's talk about
It
it
was
for a
both of us.
second, then we gotta get the other ones up there. But here's what Joe Garvey and maybe Jay did. They moved the two over to the other side. When you're solving an inequality by hand, you gotta have 0. So they moved the 2 to the other side. So then they had x plus 5 over x minus 2. Okay? They got a common denominator, so they multiply top and bottom by x minus 2. There's the common denominator, and then they worked through all the numerator and got back, negative x plus 9. So then they went to the number line, and they put a dot at 2 and a dot at 9.
Yep.
Now, the reason the dot goes at 9, this is a little confusing, I get it. But you need to put a dot wherever this equals 0. That's where the dot goes. So negative x equals negative 9, x equals 9. That dot came from the numerator, so it is solid. The dot that came out of the denominator is never solid. So then, he picked a number, I don't know what number he picked. So if he picked 0, for example, 0 is over here. When he plugs in 0, he gets a negative number that is not positive. So he did shade, and he did. That's how we got it.
Both of us.
Right, sure.
Now, I'm going to erase this problem to give the other people room to work. Any question about that? Okay, I'd like to have B and C up here.
I haven't done C, I'm trying to do it.
I can do B.
All right, you can stretch your work over here to stay out of Dana's way.
Are you doing B or C?
Wait.
I got you, bro.
So we got.
Well, 0 would be in between these two numbers.
Yeah.
So you plug 0 into your problem. If it turns out negative, less than 0, you shade where the 0 is. If it doesn't turn out negative, then you don't shade that section.
Negative.
This is not going to be a group exercise on test day, folks. You have to figure this out.
Less than 0.
Feels great, Miss Ford.
Plugging,
Trying
to get 5. Why is it negative? Trying to get 5.
Notice how he wants to take the credit when the problem really should tell us a story about Jerry.
Joe, you gotta admit, I did tell you to plug in the 0.
True, but I can negative 12.
Yeah, I don't know. You told me, what do you do now? And I said, you plug in 0. Yes, you did. Yes, you did. Yes, you did. Don't even care.
What makes it negative?
I like you have to plug it in.
Alright.
Yeah.
Yeah.
You didn't get it. If it's less than, make sure.
I think the green is correct also.
Yeah, no, that's good.
Oh wait,
So
Owen.
you're struggling
Owen,
with
I have,
green.
right, this green is just a
Looks right.
Green,
We have,
We
we
now
have
have
to
a
start.
problem where there's
Jack had it right. Owen did.
Okay, because you divide with max.
Switch to me.
green had to be backwards, right?
That means,
So she chose the factor by
SB negative
grouping.
So, these are shit.
If things don't, Jack, if things don't factor by grouping, or if you don't want to factor by grouping, you'll do
I'm saying you can
synthetic
shade it
division,
before
right,
you-
guys?
Yeah.
Okay, she didn't need to do that, she could have, she didn't need to. It factors by grouping, and she didn't write it down, but she ended up with x plus 3, x plus 1, x minus 1. So that's where she got her open dots at -3, -1, and 1.
And if you did, for some reason in synthetic division, you move the 3 over and divide by 5 and 3, like it'd be, or
No.
would you
It
find?
would be 1, 3, -1, -3, and you would just divide.
It would be, you know, do the PR, right? Oh.
It would be just that, you would leave it just like that, not move anything.
Yeah, what would you put in the?
Whatever your guess is.
Okay, yeah, that's like that. It'd be 3.
Now,
Could
I don't know what number she tried, I'm gonna put 0 in. 0 gives me 3 times 1 times -1. If I put zeros in. Is 3 times 1 times -1 less than 0? Yes. So where 0 is on the number line, I shaded. And then skip, shade. So that's how she got that answer. Perfect. All right, does anybody have a question about that? All right, and then let me see if I match six.
Open circle.
all the nominate.
Let's have an open circle. Open circle of 2.
Open circle. 2 and 0. No, it'd be,
Okay, I need to look at this for a second. So yeah, you guys did a good job. The dots I'm in total agreement with. These 2 would be open and that one would be closed. These 2 came out of the denominator, right? And denominator dots are gonna be open regardless of anything else. That one's gonna be closed because of the sign in the problem. Now, what number did you check, Dana?
-5.
You checked -5. So when you put in -5, his numerator came out to be -3. And that would be -3. And that would be -5. What kind of a number do I get? Whoa.
Ooh, negative. Oh, we got no, we got positive.
You got a
Oh,
positive.
no, we got negative. We got
You
negative.
got negative.
3
A negative over 2
negatives are going to be,
Negative. I meant negative. You
Negative.
Oh, negative. Elijah, right?
You guys-
Negative.
Sure.
No, you said you
No,
did
no,
that.
no.
Everything
3
is done
negatives
that.
are
No,
going
I
to
got
be
lied
negative.
I got lied to.
These 2
I like
negatives,
it.
but it leaves you with that one. So when I put in, would you say -3? No, -5. When I put in -5, I got a negative number, is that what I wanted?
No.
So this should be shaded, and this should be shaded. So the answer is -infinity to -4, or -2 to 0. All right? Okay, I want to take a minute. We'll pick up here next time. We'll review some more next time. I need you to listen carefully.